In this video, I will be discussing the second module from the data warehousing and data mining subject. So in this particular video, we are going to cover what is data warehouse and its basic concepts, data warehouse modeling, that is data cube and OLAP, data warehouse design and usage, data warehouse implementation, data generalization by attribute oriented induction. So in this particular video, I will be giving you the details about these concepts, which are in the important points required for the exam perspective. Okay, I don't go into the detailed concepts, but I will provide you the basic information about all these concepts that are covered, so that you will be this video will be useful for your last minute studies during your examinations. Okay, so let's start with the first concept. So what exactly is a data warehouse? Data warehouse can be defined in many different ways. Okay, so it's a decision support database that is maintained separately from the organizational operational database. Basically, it's an integrated data store where you store all your data. As a backend, a data warehouse is a place where you'll store all your data related to your organization and its business process. Okay, a decision support database is maintained separately from the organizational operational database. Operational database is something which is exactly query processing based, where you require a real-time processing, where you require results. Okay, so they're exactly the different architecture to store your data physically. Okay, so that is the data warehouse. So support information processing by providing a solid platform of consolidated historical data for analysis. Okay, it's a information processing system and provides a solid platform of consolidated historical data for analysis. That is, if you have an historical data, you can analyze and you can give important patterns of data behavior, which is important for decision making. Okay, so whatever the patterns obtained from data analysis of this data warehouse is really very helpful in the business process, and it is also good for business intelligence. Okay, so how can we define our formal definition for data warehouse is it is subject oriented, integrated and time variant and non-volatile collection of data in support of management decision making process. As I said before, mainly the important thing about why we have a data warehouse is for business intelligence. This is what exactly the data warehouse is. It is subject oriented, integrated, time variant and non-volatile. Subject oriented means any subject like sales, marketing, business, recruitment. Okay, that is subject oriented. Integrated, for the sales you have to integrate the data from multiple locations where sales happens, and it is time variant, whether you want monthly, or yearly or quarterly or something like that. Non-volatile means it is physically stored, it doesn't vanish by whenever there is no use of it. Okay, so data warehousing is a process of constructing and using data warehouse. Subject oriented, so if the question will be asked what is data warehouse, explain briefly or explain in detail for 6 or 10 marks, you have to explain what is subject oriented, what is integrated, what is time variant. Okay, separately. So subject oriented means organized around major subjects of customer, product and its sales. As I said before, it is related to marketing, sales, analysis, profit, loss or something like that. Okay, focusing on the modeling and analysis of data for decision makers and not only daily operations or transaction processing. Provide a simple and concise view around particular subject issued by excluding data that are not useful in the decision support process. Integrated, as I said before, integrating heterogeneous data to obtain historical data, you have to integrate data from multiple sources. So data warehouse is constructed by integrating multiple heterogeneous data sources like relational database, flat files, online transaction records. So you require data cleaning here for data integration. So data cleaning and data integration techniques are applied to ensure consistency in naming conventions, encoding structure, data attribute measures are among these. Okay, so when data is moved to the data warehouse, it will be converted. Okay, it will be normalized, it will be simplified, it will be generalized. So before the data is fed into the data warehouse, it has to go through some pre-processing, cleaning. Okay, so then the integration happens. Time variant, time horizon for the data warehouse is very significant and significantly longer than that of operational system. Operational database contains only current value of data, whereas the data warehouse data provide information from a historical perspective, for example from past 5 years, from past 10 years, like that. So every key structure in the data warehouse contains an element of time, explicitly or implicitly, but the key of the operational data may or may not contain the time element. Data warehouse is non-volatile. The physically separate store of data transformed from the operational environment. Operational update of data does not occur in the data warehouse environment. Does not require transaction processing, recovery, and concurrency control mechanism, as we can see in the database system, which requires all these. It requires only two operations in accessing, that is initial loading of data and access of data. This is a very important question in exam. Definitely this question will come. Differentiate between OLTP versus OLAP. OLTP means online transaction processing versus online analysis and processing. Okay, so both are two different models of data computation. Okay, so here there are OL differences. I think there are 8 difference. No, not 8. 4 plus 2 6 plus 4 5 11 differences are there. You can, like, if you remember 6 to 8, it is fine enough. Okay, so OLTP and OLAP. The first one is users. Who are the users of OLTP? Clerk and IT professionals, and OLAP knowledge workers. OLAP is comes under data warehousing, whereas OLTP comes under real-time query processing. Okay, so OLTP and OLAP with respect to users, clerks and IT professionals are the users in OLTP, whereas knowledge workers in OLAP. Function, as the name suggests, OLTP, online transaction processing, day-to-day operations are recorded there, whereas OLAP is for, as it does analysis, it is for decision support. Database design is application oriented in OLTP and subject oriented in OLAP. Okay, so data, current, up-to-date, detailed, flat, relational, isolated. Okay, whereas in OLAP it is, as I said, the definition itself suggests that it records historical data and records and show that historical data in a summarized way, multidimensional, integrated and consolidated. Usage is repetitive. OLTP usage is repetitive, whereas OLAP is ad hoc. Okay, you don't require in real time, you don't always require OLAP. Okay, access, read and write, index, hash on primary key. Okay, with respect to OLTP, whereas OLAP requires lots of scans because it requires analysis. Unit of work, short simple transaction, that is atomic transaction in OLTP, and whereas OLAP is as it does analysis, it is nothing but a complex query processing. Number of records access, tens. Okay, here number of record access is millions for analysis. Users, thousands of users are there for OLTP. More than 1,000 users will be there for OLTP, whereas OLAP, it is done by knowledge workers, so hundreds of users. Database size 100 MB to GB, whereas 100 GB to terabyte, as it records historical data. Metric, transaction throughput, query throughput and response. So these are the important differences. Okay, you can write in your own words, as you have, you can it's using your common sense, you can easily differentiate between an transaction processing and analysis processing. This is a data warehouse architecture. It is called as a multi-tier architecture, and also you can call it as a 3-tier architecture, as it has 3 main layers of data sources, data storage and OLAP engine. Okay, so in the data sources, from where exactly the data is fed into the data warehouse, other sources, operational databases. So whatever data source you have, online data, web data, business data, bank related data, weather forecasting. So all the data can be integrated into fed into the database. So before the before the data is fed into the data warehouse, it has to be extracted from the sources, it has to be transformed, and it has to be loaded, and it has to be refreshed. Okay, so once the data is fed into the data warehouse, you will be having its metadata. You will monitor and integrate the similar types of data. And when you have a data warehouse where you cannot make out what information is stored, so data warehouse will have data marts. Okay, data marts will be like a subset of a superset. So subset, if it has a subset, then it will be easy for gathering the information. Like for example, if you want the data related to movies, you have a data mart for movies. If you want the data related to the climate thing, you have a separate data mart for climate. For online sales, the data will be there for different data mart will be there for that. Okay, so like that. Next we have OLAP servers for this. Once you have data warehouse, there will be OLAP servers which serve the applications, okay, which provides access to the data warehouse. Okay, you definitely require an server kind of thing. Okay, so OLAP engine will be there. OLAP engine consists of OLAP servers. So finally we have front end like analysis, query, reports, data mining tools to obtain the patterns, the things that are supportive for the decision making. So this is a multi-tier architecture of data warehouse. Again, you may get 2 marks question to define the following. There are basically 3 data warehouse models. One is enterprise warehouse, data mart, and virtual warehouse. Important question. If you have question like define the following, they may give these 3 things: enterprise warehouse, data mart, and virtual warehouse. Enterprise warehouse collects all the information about subjects spanning the entire organization. Okay, whereas data mart, as I said before, subset of the corporate wide data that is a value to be a specific group of users. Its scope is confined to specific selected groups such as marketing. Data mart, independent versus dependent data marts will be there. Okay, so which are independent means anything can be fed into the data mart. Dependent specific to some concept. Okay. Virtual warehouse is a set of views. As you have studied already in DBMS, views is nothing but the virtual table. Okay, so set of views over operational database. Only some of the possible summary of views may be materialized. This is also an important question on ETL, that is extraction, transformation, and loading. Extraction is nothing but feeding data into the data warehouse, that is getting data from multiple heterogeneous and external sources into the data warehouse. Data cleaning, that is detecting errors in the data and rectify them when possible. Data transformation, convert the data from legacy or host format to the warehouse format. Load means sort, summarize, consolidate, compute views, check integrity, and build indices and partition. Refresh means propagate updates from data sources to the warehouse. The model of storing the data in the data DBMS is tables, and in the spreadsheets it is again a tabular structure. But what format, how exactly the data model, what exactly the data model of storing the data into the data warehouse? It is data. It's a multi-dimensional data model for storing or accessing data from the data warehouse. Data warehouse is based on multi-dimensional data model which views the data in the form of a data cube. A data cube such as sales allows the data to be modeled and viewed in multiple dimensions. So these dimensions are called as dimension tables, such as item. We can call it as item with the attribute item name and brand type, or time. The attributes are day, week, month, quarter, and year. Next we have fact tables that contains measures such as number of sales you had, and the amount sum total, minimum, maximum, all those you have in the fact table. So you have dimension tables and fact tables. So 2 important structures which holds the data in the data warehouse are dimension tables and fact tables. So in data warehouse, the literature, you have a base cuboid. So in the next slide we have that. So this is a lattice of cuboid, that is here you need to understand what exactly data cube and what is a cuboid. Data cube is nothing but collection of cuboids. Okay, collection of cuboids, like we call as a table as a collection of rows and columns. So similarly we have a cuboid and a data cube. So collection of cuboids are nothing but a data cube, and a cuboid is a like one dimension, one instance of data, or one instance of collection of attributes or with respect to a subject. Okay, so here we have in this lattice we can see the data at apex at a 0 dimension, in 1 dimension cuboid, 2 dimension cuboid, 3 dimension cuboid, and 4 dimension cuboid. Here 1, 2, 3 represents the attribute here. Here you have in the base cuboid you have the more detailed information. When you drill up, when you roll up, you can reduce the dimensions to a lesser number. That is for a more generalized dimension, you have to climb up into the cuboid. So this is an important slide representing the cuboids and the data cube. A very important question in the data warehouse, that is the dimensions and measures. Modeling models that are there in the data warehouse. Different models that are there in the data warehouse. So we have 3 different models, that is star schema, snowflake schema, and fact constellation. Very important question, like you will be asked about the important models you have in the data warehousing and data schemas of a multi-dimensional data model. What are the 3 schemas for multi-dimensional data model? Star schema, snowflake schema, and fact constellation. Very easy it is to understand. When we see the figure, we can really easily understand. Like basically you need to remember 2 things are there, 2 structures to store information inside a data warehouse, 2 models, that is a dimension table and the fact table. So using dimension table and the dimension table and fact table, you can organize these schemas. So basically in what happens in the star schema, there will be a centralized fact table and surrounded by or connected by its other dimension table. So here we have a sales fact table which stores all the measures of the measures of computation of all the other dimension table. We have a dimension table such as time, branch, item, and location, for which there is a central table called fact table. So this is the star schema. Next we have snowflake schema, similar to the star schema, but we have extended version of dimension tables here, or a more detailed tables of dimension table here. So we have a centralized fact table. Next we have an item dimension table, for which we have supplier extended table, that is item supplier. Okay, supplier dimension table. So this is a snowflake schema. Next we have fact constellation, where we have multiple fact tables or 2 or more fact tables connected to each other and connected to the dimension table. So here we have sales fact table and shipping fact table, which is again connected with the same dimension table, that is item and location. So this is fact constellation. So very important question and very easier one also. You can like easily understand this: star schema, snowflake schema, and fact constellation. This is also an important question on data cube measures. What are the 3 categories of data cube measure? There are 3 categories of data cube measures. One is distributive, algebraic, and holistic. Distribute data cube measure is nothing but if the results are derived by applying the function to n aggregate values is the same as the derived by applying the function on all the data without partitioning. So this is nothing but count, sum, min, max. So where you will obtain the same result if you aggregate all the values and apply the function to it, or derive by applying function to all the data without partitioning. So you'll get the same count, same sum, and same min, max. So this is distributive data cube measure. Next we have algebraic data cube measure. If it can be computed by an algebraic function with m arguments, that is where m is a bounded integer, each of which is obtained by applying a distributive aggregate function, that is average, minimum of n values, standard deviation are the examples of algebraic measure, data cube measure. Next we have holistic data cube measure. If there is no constant bound on the storage size needed to be described as a sub aggregate, so median, mode, and rank. Okay, so these are the 3 different data cube measures we have. Before we get into the OLAP operations, we need to understand this particular multidimensional data where we have dimensions such as product, location, time, hierarchical summarization paths. That is, industry will have a category, then product, region will have country, city, office, year will have quarter, month, week. So we have to understand these multiple dimensions to understand the OLAP operation. So there is a sample data cube where we have a date and the product and the country, multiple dimensions. Okay, so next we need to understand what the typical OLAP operations. Very important question. I definitely ask question on OLAP operations. So typical OLAP operations or different OLAP operations you have in the multidimensional data model. So we have different OLAP operations such as roll up, drill down, slice and dice, pivot, and other operations like drill across and drill through. So what happens in the roll up is it's a summarized data. Okay, so by climbing up in the hierarchy or by dimension data. So in the cuboid I had explained you, so when you go up from the base to the apex, you will get a more generalized view. Okay, so that is a roll up operation by climbing up in the hierarchy or by dimension reduction. Okay, by dimension reduction also you'll get a generalized or summarized view. Okay, so next we have drill down. If you need a more detailed view, detailed results, then you have to get into the reverse of roll up, that is drill down, from higher level summary to the lower level summary or detailed data or introducing new dimensions. Next we have slice and dice, that is project and select operations that we do in the in DBMS we like project and select. Okay, so select project with respect to the columns and select with respect to the rows. Okay, so next we have pivot, reorient the cube visualization from 3D series to the of 2D planes, like rotation. It's a rotate operation. Okay, so you will better understand with the example. Drill across involving involving more than one fact table, drill through the bottom level of the cube to its backend relational tables. See, in the roll up we have for location dimension we have like cities, important cities of US and Canada. In the roll up operation with respect to the cities, we have next countries. We can like roll up to Canada and USA. So what happens in the drill down here with respect to the time dimension? So here it is been like they have used quarter 1, quarter 2, quarter 3. Instead we can drill down to months. Okay, January, February, March, April, and like that. So in the slice and dice we have selected here the columns. Okay, one dimension we have select here, we can select in the project 2 dimensions. Okay, so like that, slice and dice operation. So what happens in the pivot is nothing but it's a rotation, a 3D rotation. Okay, so here we can see the location is at the x-axis and item is at the y-axis. So when we shift the dimension, we have item in the x-axis and location in the x-axis, like that. It's a different dimensional view. So these are the basic OLAP operations. So 10 marks question will be there. This is looking a very big diagram, but it is very simple. Next, in the data warehouse design process, we have 4 views regarding the design of the data warehouse. Top-down view allows the selection of the relevant information necessary for the data warehouse. Data source view exposes the information being captured, stored, and managed by operational systems. Next, we have data warehouse view consists of fact tables and dimension tables. Business query view sees the perspective of data in the warehouse from the view of end user. So we have 4 different views, that is top-down views, top-down view, data source view, data warehouse view, and business query view. So in the design process, we have top-down, bottom-up approaches for combination of both. Top-down approach starts with the overall design and planning. Bottom-up starts with experiment and prototypes. From the software engineering, we have waterfall model and spiral model. And next we have typical data warehouse design processes, that is business process, grain of the business process, dimensions and measures. So this diagram shows a data warehouse development recommended approach. In the data warehouse usage, we have three kinds of data warehouse applications, that is information processing, analytical processing, and data mining. In the information processing, it supports querying, basic statistical analysis, and reporting using crosstabs, tables, charts, and graphs. In the analytical processing, we have multi-dimensional analysis of data warehouse, that is multi-dimensional analysis of data warehouse data, supports basic OLAP operations, slice, dice, drilling, pivoting. Okay, in the data mining, we have knowledge discovery from hidden patterns, supports association, constructing analytical models, performing classification, and predicting and presenting the mining results using visualization tools. Efficient data cube computation. Data cube can be viewed as a lattice of cuboid. So this already we know. The bottommost cuboid is the base cuboid. Already I have shown you in the diagram. And the topmost cuboid is the apex, contains only one cell. So how many cuboids in the n-dimensional cube with the levels? In the n-dimensional, suppose we have three cuboids, that is 2 to the power of 3 is 8, that is we have like 8 cuboids from the 3 dimensions. Okay, if we have 4, we have 16 cuboids from the 4 dimensions, like that. If you have n-dimensional cube, then we can get t is equal total number of cuboids is equal to pi of I to n li plus 1. Li is nothing, L is nothing but number of levels in the dimension. Okay, so like that. So the technique for materialization of data cube, materialize every cuboid, full materialization, no materialization, and some partial materialization is a technique. So challenge here is like in the thing, what happens is when we have to compute or pre-compute the number of cuboids, we requires a lot of storage. So that's why to face this such challenge, we can go for partial materialization. So selection of which cuboids to materialize is based on size, sharing, and access and frequency. The compute cube operator. This is a very important question. The compute cube operator and the curse of dimensionality problem. Okay, so definitely this question will be there in the exam. So cube definition and computation in DMQL. Define cube, that is sales item city year, similar to the like what create table. Okay, sum of sales is an again function. Okay, compute cube sales. So that is transformed into an SQL query here, and you can like compute cuboid is operational for group by operation. Okay, how to perform compute cube operator is it's a group by operation. Next we have access methods in OLAP. Okay, access methods are, there are two access method. One is bitmap index, and another is there is one more method I will tell you in the next slide. So bitmap index is index on a particular column. Okay, index on a particular column like region, type, or like that. So each value in the column has a bit vector. Bit operator is which is an operation which is a faster operation. So length of the bit vector is equal to number of records in the base table. Okay, ith bit is set if the ith row of the base table has the value for the index column. Not suitable for high coordinate domains. A recent bit compression technique like word align hybrid makes it work for high cardinality. So here you have a base table for region and type. Okay, so here the customer ID is set as a bitmap index like C1 to C5. So when we go into the region table, we have a record ID for that, and when we go into the type, we have record ID for that also. So when we have Asia, we'll set to 1. When we have Europe, we set to 1, and we have Asia and again set to 1. Asia, America is set to 1. Like when we have that value, it is set to 1. Bitmap index is set to 1. When we have index on type, we have retailer, dealer. Okay, so that is set to 1 whenever there is an entry for that information. Okay, so like this we have bitmap index. Join indexes are very similar to the join operation in DBMS, like we join the tables based on primary key and foreign key. So here join index, we have RID, SID. Okay, RID may be the primary key and SID may be the foreign key. So traditional in the map the values to a list of record IDs. It materializes relation join in JI file and speeds up the relational join. join operations speed up access. Okay, so that we have already studied in the DBMS. So in the data warehouse, join index relates the values on of the dimension of the start schema to rows in the fact table. Okay, so fact table sales and two dimension city and product. Again, we have an important question on OLAP server architectures. That is, there are three architectures: ROLAP, MOLAP, and WHOLAP. In the ROLAP, what happens, as the name itself suggests, it's a relational OLAP. Use relational or extended relational DBMS to store and manage warehouse data and OLAP middleware. Include optimization of DBMS backend, implementation of aggregation, navigation logic, and additional tools and services. It comes with a greater scalability, whereas the MOLAP comes with a faster access, sparse array-based multi-dimensional storage engine, fast indexing to pre-compute summarized data. Hybrid OLAP, as the name itself suggests, it's a combination of ROLAP and MOLAP. For example, the Microsoft SQL Server. So flexibility is high, and greater scalability and faster access will also be there. Okay, so low-level relational, high-level array. Specialized SQL servers are there called Redbrick. Specialized support for SQL queries over the stack, Snow. Basic principles of attribute-oriented induction.